Thank you for having me here today. I'm Juan Lage. I am a principal engineer in the CMA business unit, INSBU. It's, as you know, the business unit within Cisco that is responsible for the 9K, or Nexus 9000, Nexus 3000, and ACI portfolio. I'm based out of Europe. I am originally from Spain, so you're going to have an exotic European accent for a change, perhaps. More often than not, you may have seen my colleagues from the US presenting these topics, Joe Onisik, Carly Stoughton, or people like that. What I have done here today is I have a set of slides to explain you what are the capabilities with ACI microsegmentation and how they contribute to enhancing the security in the data center and also simplifying operations. I have not done like a deep dive of how things work for two reasons. Number one, we only have about 25 minutes, I think, and number two, it's difficult to prepare for a diverse audience, and I don't know exactly what your background is. So please chime in, ask questions if you want to know more of the details. Happy to dive in as much as we can, of course. Now, what I have done here is this microsegmentation topic has been somewhat, has generated a level of animosity, I should say, in social media and in other environments where, one vendor claims that I do microsegmentation, you don't. No, I actually do it. So I think it's fair enough to always start with what do we mean by microsegmentation, because certainly all vendors, will try to use the terminology to their own advantage, and it's a legitimate thing to do, of course. So what we mean here is obviously customers have been segmenting applications and providing a level of security between those segments using traditional concepts for a while, like putting different segments on different subnets and mapping those subnets to different VLANs. So clearly, microsegmentation has to be moving beyond that, right? We need to be able to segment with a more granular level. And what we think it's about is to be able to define segments that can be as far or wide as you need, and define policy automatically between those segments where you have endpoint granularity, where at any moment you can make an endpoint, any single individual endpoint, from one segment to another. And then that segment may actually have 2 endpoints, 1 endpoint, or 100 endpoints, but it's about having the granularity of defining on a per endpoint basis what policy will need to be applied. Which is not the same thing of saying every endpoint will have its own policy, which, it's an interesting thought, but it's probably not a practical or even a necessity or a practical thing to do. Now, it has to be automated. It has to be independent of location, both from a physical standpoint, where endpoints can actually be anywhere in the racks in the data center, where endpoints can be of any IP addresses. So we no longer define IP addresses as or subnets as the way to define policy. And the best way to look at what we can do to fulfill this from an ACI perspective is to look at an example. And I actually decided for a very basic example to keep it really simple. Let's imagine that you have a company that is running a web shop, or it could be just a blog really, but any application where you have some web server hosting your content and then some database where you just perform a transaction. And then you may have some perimeter firewalls today that largely are going to be physical devices, some firewalls and accompanied to some load balancers. Perhaps you push your SSL offload to that hardware device. And some of these tiers may be running virtual. Most of them will run virtual today, but some of them may still be running on bare metal, right? So this is the typical thing that you can find anywhere else for a blog or things like that. And most companies will also have an accompanying development or test environment. And for simplicity, you probably have dev, test, and prod. But for simplicity, let's just say that there's a test environment here for our example. Now, in a traditional architecture in the data center, customers will have perhaps a 3-tier model where you have, at the distribution layer, you connect your firewalls, you connect your load balancers. And as I said before, you segment those applications using subnets and VLANs. And those subnets will be tied to specific racks. And then you have probably vSphere clusters where you implement the virtual machines for different parts of your application, perhaps on one area, and other parts of the application on another area, perhaps on other clusters. And typically, customers also have separated clusters, sometimes even separated vCenters for your test or development environment, right? Certainly, different clusters is a very common thing to see. Now, the services are applied at the distribution layer. So for north-south, that means that all the filtering has to happen on those firewalls. But for east-west, the filtering, if you want to have it, typically will happen at those firewalls as well. So you end up with a very large firewall rule set there that is really doing more or less ACL management. Some people actually do ACLs instead of firewall ruling, right? So that you actually don't have to push all the traffic all the time to the firewall, right? But some people actually have to do both, because sometimes the SecOps team and the network team have different requirements, or simply because that's the way we've done it forever, right? But net, the challenge and the complexity is, well, number one, you create bottlenecks. Number two, and perhaps this is really the biggest problem for most customers, is the operational nightmare. Is you end up with all these firewall rule sets or ACL rule sets that are very lengthy, that have hundreds, thousands of entries. Some of them are actually bogus entries or garbage from all applications that haven't been decommissioned, and nobody wants to change the rules in case actually they belong to something that is not decommissioned and you're going to break something. So this is the problem that people is trying to solve, and we can see how we solve that problem by migrating to the ACI policy model. Now, we can migrate to that model in multiple ways. I mean, you can perform a complete transformation of your data center and go into a leaf-spine architecture, or you can actually, ACI demands or mandates a leaf-spine architecture, but you could always mimic a distribution layer using leaf switches, for instance, like I'm depicting on this slide. That is not a requirement, but I'm assuming that perhaps your cabling is built that way so that you actually want to keep your load balancers or firewalls physical in the same place where they were, or maybe you're virtualizing those firewalls and those load balancers as well. So that's kind of like just to follow on with the flow and the example, but it's not a limitation. Question?
Is this a standard model, a basic fundamental, or?
So the question is whether this is a standard model for how we implement things. I wouldn't say it's a standard model. I'm just following up from, this is a pretty standard model, right? Do you want to deploy ACI following that model? Depends. I think for many customers, it's going to be dictated by their cabling environment and where they want to put different devices and appliances, which can follow this model. But by no means this is a best practice or a standard model or anything like that. It's just to follow the example. So again, I'm just following the example, kind of like to say, you continue doing things that you were doing, but you're just going to do them better or easier. That's pretty much what it is.
Yeah, but you have to start somewhere.
You have to start somewhere. That's exactly the point, yes. So the first point where you start is you define an application network profile, which in ACI is the way you define connectivity between applications for representing that application. And that could look something like this on the graphical user interface of the APIC. This can be done also, obviously, driven by a cloud platform, and we actually work with many of them. I'll talk about them. Or this could have been done by the CLI, or this could have been done by the GUI and scripting. Anyway, but essentially, you create what we call endpoint groups that will group the virtual machines that perform specific functions in the application. Like in this very basic example, you have the database endpoint group on MySQL servers and the Apache servers as the web endpoint group. Now, these actually are completely subnet independent. When you're defining these endpoint groups, you're not really tied yourself to specific subnets, meaning you could have, in this particular example, the databases and the Apache web servers on the same subnet. The EPGs are not subnet bound. That's what I'm saying here. Now, for historical purposes, and probably your IP address management already has different subnets, and you can continue using different subnets, but that's not necessarily a necessity. Similarly, the connectivity between these applications is going to be mandated by what contracts you define between them. Those contracts will control the communication east-west between the application tiers, and also the definition of the communication to external devices or external interfaces, which we can do by creating external layer 2 connectivity to existing fabrics perhaps, or external layer 3 connectivity to the existing routers. Again, at this point, you do need just to announce the subnets, because obviously you need to route them outside, but the policy itself is subnet independent. In these contracts, you do not define subnets, right? These contracts are subnet independent. Contract is just saying this group of endpoints can only talk to this group of endpoints as per these particular protocols ports of connectivity. So that means already that your east-west filtering, which is represented here by these green arrows, is already automated and is already moved away from the ACL management to a contract-based model, which is again subnet independent. Now, the next thing is you could continue using your next generation firewall or load balancers that you have already in place. So you could again deploy new ones somewhere else in the topology, virtual or physical. But for the sake of the example, let's assume you want to continue using the existing firewall and load balancers for your north-south insertion of perimeter rules. That's something that you can automate by extending these contracts with what we call a service graph, that I'll provide more details in a little bit. But essentially it's going to say the traffic between my external networks and my Apache web server will have to flow through this firewall and will have to have a specific firewall rules. The traffic between these two applications have to go through a load balancer and has to go through specific services. So that's added to the contract via service graphs. And the final point is that here we're looking at the application, the virtual machines, but the same model can be used to represent the actual infrastructure. So meaning, for instance, the physical servers on which those VMs are running, you need to secure them as well. The SIMC, the management ports, the fact that on the vMotion VLAN there should only be motion traffic, right? The fact that on the management interface or VM kernel NICs should only be specific ports and protocols allowed to communicate with vCenter and nothing else. All of that can also be built and represented using contracts, right? Which not depicted on the slide, but essentially is the same model. So this model of segmentation and policy is not just for your applications, but also for the infrastructure, which we think is a complete security model and a key benefit compared to other solutions that are available in the marketplace. And let's look at that development or testing or both environments. How do we handle that? Well,
Quick
yes?
question before you go on. So I've heard a couple times regarding ACI this week, the concept of a contract. I'm not sure exactly what that means. Can you just explain that real quick?
Okay, so excellent question. Thank you for bringing up. What is the concept of a contract? So the contract is what's going to define the connectivity between endpoints or endpoint groups in the fabric. So what it is a definition of filters that allow connectivity. So you'll define, for instance, TCP/80, and that's a filter for web, or TCP/443, and that's a filter for SSL. And you may define as well other ports and protocols that you want to apply. You group all of those, and you say this contract is going to enable you to have access to 80, 443, and perhaps a backup service or something like that. That's a contract. And now you say this group of endpoints is going to provide that contract. And what we'll do then is any IP addresses that have to fit in there will be, dynamically enabled to have exposure to those ports. That doesn't mean that anybody can communicate to them, right? There has to be another group of endpoints that consumes that contract, right? And that is what kind of closes the loop, right? And enables that connectivity. Those contracts are bidirectional in nature, and those contracts are by definition, well, actually that's depending, it's a click option, can also match on TCP SYNC and TCP NAC flags, right? So you can actually keep track of, established sessions or non-established sessions. Does that help?
Thank you. Yes.
Excellent. Now, there are ways to enhance those contracts. That's the security component. The contract also allows you to define additional things, like, for instance, a service graph, which I'll display later, which is this connectivity, in addition to the contract, needs to be filtered by a next-generation firewall. And you can also specify the quality of service that the conversations between those groups have to follow, right? So you can add to the contract also the quality of service that is required for that specific conversation. So it's not just security, but we're talking here more about security today. So remember I said, here we're not bound to IP addresses or subnets, but ultimately these devices will be using IP addresses and will have to be on a subnet. Now, the test environment can be represented by creating micro-segmented EPGs of the existing EPGs. So you could create a test or a development Apache web server that is a micro-segment of the previous one. What do we mean by this? Well, actually, in this particular scenario, let's suppose we have these test clusters, right? The VMs on these test clusters will be automatically placed on the test EPGs, depending on whether they're SQL or depending on whether they're web, of course, by using VM attributes. In this basic example, really basic example, I'm just saying if the VM name has test in the name, it will be in the test EPG. If it has dev, I could put it on the dev EPG. You could use other attributes, more sophisticated things, of course, and you can use regular expressions as well. So net-net, what we're doing here is now, by modifying those VM attributes, you can dynamically move without any user intervention, without opening a ticket to the network guys, you can dynamically move that endpoint from one EPG to another. So as you move the virtual machine from the test cluster to the production cluster, the fabric will automatically consider that endpoint has moved to the production test EPG. And if the production test EPG included that firewall rules or load balancer configurations need to be added for any new endpoint on the production EPG, the APIC controller will automatically update the configuration or your F5s or NetScalers or checkpoints or Cisco ACIs, okay? So that works today, and we've built it in a way that we are agnostic to the hypervisor when we're working with these virtual machines. So you can use VM attributes and do this classification for Hyper-V clusters. You can do this classification for vSphere clusters. And in the future, you'll be able to do this classification as well for KVM-based environments. Now, of course, not all attributes exist equally across all hypervisors. So if you decide to use vSphere custom attributes, then, well, those rules will only be applicable to vSphere clusters, right? But as long as you stay with, let's say, the more standard VM attributes, they will work across everything. Another use case here, for instance, is you could create an EPG for quarantining VMs. And then you can create a rule that says any VM that is running Windows 2003 is going to be on quarantine and filtered by this next generation firewall that protects against vulnerabilities and only enables, I don't know, a specific set of connectivity. And the moment you apply that rule, all VMs on Hyper-V or vSphere clusters will automatically be moved into the quarantine EPG. So that is something that is also possible, and it's a common use case that we're seeing for remediation or for, again, isolating specific environments. Another common one is to have the possibility of applying a specific set of ITIL recommendations for shielding Linux versus Windows environments. So you can say all VMs that are running Windows are going to be subject to these contracts by putting them on the right EPG, or the Windows VMs will have different contracts. So there's plenty of possibilities that are open here. So with this, essentially, because all of these can be automated, and again, as the VMs can move from one space to another, you have a great story for increasing your east-west security. By the way, we've made the example focused largely on VMs, but this works as well for bare metal. I mean, if you have, again, your SIMC ports or just bare metal applications, your Pixie booting Linux servers to run specific applications, they can follow onto the same model. Now, of course, you don't have VM attributes to represent a bare metal server, so you will have to defer to either physical definitions or use the IP address or the MAC address to move into one EPG or another, which is perfectly possible as well.
Excuse me, I have a question.
Yeah.
You say that this applies either to VMs or to bare metal, but is it possible, for example, to have rules that apply to VMware clusters? For example,
okay, the question is, can we can apply this to bare metal, we can apply this to VMs, can we apply to VMware clusters? Can you say like this cluster is going to be in a particular EPG?
So basically the idea being that if you move a VM from a test dev cluster and you move it to a prod cluster, automatically it inherits the policies of the cluster.
Yeah.
And
so the use case is if I'm on the cluster that I dedicate for dev and I move to the cluster that I dedicate for production, automatically change. We don't do that today. We could. So the cluster is an object that we could use and represent on the classification, but today we don't do it. Again, we try to keep it to those that are as much common as possible. It's an interesting one. The use case is pretty good, and I can see it. Then it's also easy to break, because then as soon as anybody moves between clusters without changing anything that is particular to the VM, no metadata being involved, then it's too easy to change, to overrule security policies. So, but it's something that is interesting, and we'll look into future releases to add it. Today we're not doing it, but we definitely could. It's one of the attributes that is definitely open for us to consume.
I think you alluded to it earlier that the system administrator would come in and change the ownership or membership of the endpoint groups. I really like the idea of I'm a network engineer and I'm selfish and lazy, and I don't like the idea of taking on a duty of care in the core for ACLs for an application that I don't know as much about as the application owner. Is it common for the application owners to get into the ACI provisioning system and actually self-provision? Because
okay.
I wouldn't be I'm perfectly happy with them taking ownership of the end-to-end security and let me route their packets.
Okay, so the question is, and I'm going to repeat for the video.
Sure.
The question is it common for application engineers to actually get into the ACI provisioning and actually provision end-to-end everything they need without involving the network engineer, right? I guess that's
correct.
I would say it is definitely the aspiration. I think we have customers using it that way. By all means, they don't get into the APIC, right? It's not like you don't expect the application owners or developers to go into the APIC and configure things. But the API is exposed completely to them, and maybe by using other platforms where they are designing their application, and I'm thinking it could be vRealize, it could be Cisco Enterprise Cloud Suite, you could be thinking of CloudForms. At that environment, then yes, that's what you would use, and that would consume and create automatically contracts and filters and EPGs and application network profiles, tie them all together. And I think the beauty of this is that once that is done, it's automatically provisioned. Once that is removed, it's automatically deprovisioned. But the network engineer will always have a view of what is provisioning, what is acting, which endpoints are connected where specifically, including the context that what is the VM name, for instance, what hypervisor, where is it running, what application it belongs to, right? What filters are applied, what are the statistics of those filters. And when that is removed, you still have it in your logs, you still have it in centralized logs from the APIC perspective. And if you need to troubleshoot an application that has even decommissioned, you could still go back in time and do it. So that's how we're seeing the evolution now. So now, yeah, so we've have this east-west security, I think greatly improved, that can be dynamically changed by endpoints. As I said before, you could think of quarantining specific devices based on their operating system, and works for VMs and any workload really. And we think the elegance here is that it's the same model for everything, and it comes integrated onto your fabric. I mean, you always have to have a fabric. You just need that fabric to give you the most. And it's the same model whether you use Hyper-V or ESX today. The model for KVM will be the same. Essentially, we're pushing policy to KVM environments using OpFlex today. So what I described actually largely can be done in a KVM today using OpenStack. The only bit that we still need to add, for instance, is the possibility of moving or selecting EPG membership using attributes. That's something we haven't done for KVM. And I guess we need to figure out how we're going to do it, because Neutron is very opinionated on how these things can be done. So, but definitely something we're looking into. And one of the beautiful things is we can follow the same model for Docker containers. If you heard of Project Contiv, Project Contiv is an open source project that we have started that uses the same ACI policy model in a completely open source deployment to provide a comprehensive SDN solution for multiple Docker environments. Today it works with Docker Swarm. Very soon we'll work with Kubernetes, and in the future we'll work with Mesos as well. So we're working with, I guess, the leading cluster and scheduling solutions. And we use OpFlex, or we will use OpFlex to push that policy when ACI is the fabric underneath Contiv. So Contiv can work without ACI using the same policy model. If ACI is the fabric underneath, then Contiv can actually push the policy down to the ACI fabric, so that, like we do in KVM, the local policy is applied at Open vSwitch, but anything that is not local, we just push it to the fabric, and the fabric will do it in hardware. So it's a very neat combination for maximizing performance and scalability. It also works for bare metal, and actually this model is something that we can also extend into public clouds, which is something that we're looking into for future releases. Now we have microsegmentation working, and you could say problem solved. We actually have good east-west security. We can implement a zero trust model, certainly true for new applications. Well, not problem solved, not so fast. Not so fast because actually, if we look at the theory of attacks today, we think that enhancing east-west protection using L2, L3, L4 level filtering, which is what we do here, all vendors, is a great addition. It's a really significant improvement to minimize the scope of reconnaissance attacks if a host is compromised. So you're essentially minimizing lateral movement protection, either because a host was compromised or perhaps simply because out of social engineering, someone got access to machines and is trying to do reconnaissance on what else can be attacked or compromised. So microsegmentation plays a great role there. But the actual playground for hackers and attackers is actually beyond, right? It's at the application level. So we need to have a comprehensive strategy, and I mean we as an industry, right, where we don't try to find this one single thing that will be the solution to all my problems.
One small question. I see here you have coverage up to layer 5. So inside we are aware of the session ID. You can cover that?
Very good question. Yeah, I guess this is perhaps just a moving thing. Yes, with the ADCS, for instance, we can do connection tracking of sessions, but candidly speaking, and very clearly, we don't do, for instance, session tracking for SIP or RTP protocols in the ADCS either, right? We don't do that, no.
Okay.
So I don't want to confuse anybody. This is more of a general theory strategy or slide, right? Where I'm simply trying to exemplify that beyond the connection layer, which is ultimately still referring to ports and protocols, like for instance, FTP, can we track the ephemeral ports that FTP is opening? Yes, that we can do, for instance, right? And that's valid in there, right? Because then you don't have to open so many ports, right? You just open the ones that you specifically need and the others will be opened dynamically. But it's still port level. What I'm trying to say here is that this is where the problem lies. You allow SSL traffic, great. TCP for 48.3 is the only thing that passes, but over SSL could be anything. You could have VoIP, you could have file transfers, you could have anything. A control channel could be sent back over a legitimate SSL connection, right? So how do you detect that? How do you block that? Well, that's something that requires an application level inspection, a threat management system that is beyond what can be done today with the ACI Fabric, the ABS, or any other distributed firewall for that matter. So that's where you need to add services that help you, okay, within that filter, how do I inspect for specific URLs? How do I say this is someone accessing Facebook, I want to block it, or this is a Java malicious attack here, right? I'm not only enable you to have access to my Tomcat server, but doing some inspection on the actual Java code that is being pushed, or do SQL injection prevention. So these things require, adding service graphs, like I said before, to add those devices that have that capability. And I'm thinking here of checkpoint firewalls, Cisco ACI firewalls with firepower, Palo Alto Networks, Fortinet, and from an INSBU perspective, we're really working with the entire ecosystem, Cisco being one member of that ecosystem, and we think we have a very good, strong value proposition there, but definitely working with other vendors as well. And the way this works then is, as I said before at the beginning, we will extend contracts to include service graphs, and the service graphs will define that traffic between any endpoints that are subject to this contract need to flow through the next generation firewall or the load balancer. And when endpoints come in here, for instance, or disappear here, the API automatically will add or remove from the NG firewall rules or from the load balancer VRT pools the right IP addresses. So for instance, on the example of I'm moving from test to production, the API will automatically make sure that the NG firewall is updated and that the load balancer is updated. Mind you here, the API is not controlling the full inspection policies on the NG firewall, right? Because that's probably something that is a SecOps job, right? Is the checkpoint or ASA firepower administrator that will say what the policy needs to be for that specific flow, right? What we're doing is facilitating the fact that as endpoints come and go, the policy is applied to those endpoints or not, right?
So you redirect if you need in a policy layer 7 inspection, you would redirect the traffic. But that is always the slow pass, yeah? Not like the, let's say, layer 4, layer 5 inspection, which is in the fast pass. This will be slow pass, redirected, and then come back
yeah,
to
so
the
the question is
flow.
we need to redirect for layer 7 inspection, yes, and then the comment is a slow path versus fast path. I mean, clearly the performance of layer 4 level inspection can be done in hardware for the most, right? Connection tracking is also relatively lightweight, we distribute it. But yeah, clearly this requires a lot more compute power. Is it a slow path? Depends. I mean, if you put it on a VM, it's going to be very slow. I mean, a VM doing up-level inspection, regardless the vendor, is likely going to be sub-gig performance. If you put it on hardware, well, you go to the appliances from many vendors, and you probably get 20, 40 gig appliances, right? But yes, that's how it is, yeah. And that's the case for everybody today. If you want to add layer 7 inspection, you have to redirect to the devices that do it. You redirect a VM, or you redirect to a physical appliance. We can do both. This could be virtual, it could be physical. We make no distinction. And the service graph, as I said, is essentially something that you will define, you present to the APIC. This is my clusters of devices. So here's where I have my F5 load balancers, here's where I have my Citrix load balancers, whatever. And then you just reuse those and say, well, between this EPG and that EPG, I'm going to have a service graph. And now, the APIC will actually, ensure the traffic flows through and updates the configuration of those devices as endpoints come and go. Now, it's important to know that this also is available through the same API. And if you're using, for instance, vRealize, you can use this as well to create or to attach load balancing or firewall services to your multi-machine blueprints. Or if you're using Cisco Enterprise Cloud Suite, you can do that as well, or in fact, with pretty much any cloud offering, right? So here, specifically to Cisco, we think we have a very neat combination where we combine the native fabric security policy model and microsegmentation with the full suite of Cisco security products. Cisco ACI with firepower, advanced malware protection, and OpenDNS can all be combined together to create a comprehensive solution for security. Then again, as I said before, we actually partner with many other vendors, and I think I have it on this slide, where we're agnostic from a service graph perspective. We can partner with a number of options. Again, Fortinet, Palo Alto, Checkpoint, and others. So that's really what I have today. I don't know if this helps to clarify what we can do and cannot do in terms of microsegmentation. Yeah. Are there any other questions? I still have 30 seconds.
I'm not a network engineer, but I'm more a virtualization and storage engineer.
Okay.
And I want to know if you have some template about object like vCenter, ESX host, or ILO, HP ILO, or we need to build every object with the port that we need to open. Okay.
It's a great question. So the gentleman is saying, do we have already sort of templates of how do you create an application network profile for vSphere environment, who connects to vCenter or not, or for management environments of HP servers or Cisco servers, or say for Exchange and things like that. So so far, I haven't seen that we're concentrating any of that in a specific place. Some people have begun posting some of those on GitHub and things like that. And we will stay tuned. In the next couple of months, we will come out with a very neat solution for helping you build those application network profiles, literally for any application. So that's something that I cannot disclose much of it right now, but yeah, we're coming with something that will help you there.
So if I can build on the question my colleague was saying, is there any sort of online community for people working with ACI where people can share this kind of templates or their experiences or whatever?
Yeah, the question is actually, are there communities already online where you can share some of this information and learn from what others have shared? Absolutely there are. I'm absolutely not the right person for telling you exactly where or how. I truly apologize for that. But I know we have, I think it's DevNet. I'm truly not into marketing or social communities, but we do have a healthy number of people contributing on GitHub. Like for instance, not long ago, a student in Belgium contributed a device package to be able to use Nginx as a load balancer integrated with ACI. So on GitHub, you'll find plenty, but on Cisco, there's also a general site or tool for contributing and collaborating on multiple Cisco technologies, and ACI is definitely there, yeah.